Welcome to Access List presentation, or one of the first presentations. So Access List is one of the toughest areas that network engineers or new network engineers find to study for and apply and troubleshoot. So I'll put it in the same kind of league as subnetting really. Subnet and access lists are the two toughest things. The other stuff you can kind of get your head around eventually. I think really with access lists the best way to learn anything is to do some access list labs, and as you try and do the labs, or as you do the labs, you'll find yourself doing troubleshooting, finding what works and what doesn't work, and being able to put the theory into practice, because you can watch these lectures several times over, but really I don't think it's going to sink in until you start doing some hands-on configuration. So you can consider access lists really like a filter or a traffic cop of the network, where it's deciding what can and can't pass through the router. Now a lot of people think access lists are just there to block traffic or ports, but they can be used for other things, and you've already seen access lists being used in some of the labs. We used access lists for our network address translation. Also handy when you're doing debugging, because if you want to debug a certain type of IP packet, you can use access lists with it just to tailor it down and keep the CPU use on the router as low as possible. So the three main types we need to concern ourselves with as a budding Cisco engineer: standard, extended and named access lists. Standard access lists are the easiest sort really, because they've got the least amount of possible permutations to put in. So the way the router knows it's a standard access list, unless you're configuring a named version, is the number, and you put in numbers 1 to 99 when you're configuring it. Now the only thing the standard access list can look at is the source of the traffic. It can either look at the source network or the source host address, but that's it. It can't look at what's actually in the packet, what type of protocol. It can't look at where it's destined for either. Now extended is the main sort of access list you'll use as a network engineer. The only shortfall is it filters a lot more, and you've got a lot more granularity, but because of that it actually has a lot more permutations for you to have to put in. So the router knows it's an extended access list because it's numbered 100 to 199, but it can filter, as I said, on a more robust range of services and protocols. The named access lists are the sort of newer type of access list that's available. Fair bit more user friendly, but the drawback is it's got a slightly different way of configuring it as compared to standard and extended. So really it's a third way you've got to learn to configure access lists. So you're giving your access list a name, and then you tell the router if you want it to be a standard or extended access list. So stuff we presume you know when you're configuring your access list really is all of the common port numbers, which we've covered in other lectures, but you really do need to nail down a list of about 15, possibly even 20 port numbers, because you'll get tested on those in the exam. And you won't be able to write your access list either. You need to know how to write the commands, because in the exam you may not be able to. You can use the question mark key, but you can't really fall back on that during the exam. There are unfortunately a set of rules, and in my career as a network engineer I've very rarely found these rules written down. They just tend to be something you learn as you go along, or if you see the rules written down there's only one or two rules, when in fact for access lists there's a list of several rules that you need to understand. So some common port numbers which you can either pause this video, look at the cram guide, or look at other lectures, but you do need to know all of these. Command syntax, yeah, we'll come to this later on, and we're going to be doing some access list labs as well. So rule number 1. You're allowed one access list per interface per direction. I could actually put in brackets as well per protocol, but really we're only concerned with IP now. We used to be tested on IPX and AppleTalk for Cisco exams, but they're not really used anymore. So if you've got a serial interface on the outside, you can have one access list coming in and going out, and one coming in and one going out, and the same for your LAN side as well. You can have one coming in and one outgoing. So I'll come to the reason why that is, but to be honest, you should be able to configure everything you need in one access list on your router. So the router reads the access list very quickly, but it starts at the top and works its way down to the bottom, and it will stop when it reaches a match. It won't look further down your access list to see if there's a better match. So, for example, our access list here, we're looking at incoming traffic from 172.16.1.1. First line is a 10, no match. The second line is 192, no match. The third line, we're permitting the entire network 172.16. The router will match that part of the access list and permit the traffic through. The problem is this network engineer. The problem is this network engineer has put a deny that 172.16.1.1 network on the bottom of the access list, and they're trying to work out why the traffic's still being permitted. Well, it's because of the rule that the router starts at the top and works its way down and stops when it gets a match. Number 3. There's an invisible, some people say implicit, but anyway, you can't see it, so I say it's invisible, a deny all at the bottom. So imagine you've got an access list that's permitting certain traffic, possibly denying other traffic. The whole idea behind an access list is it denies everything, or it denies everything that you tell it that isn't permitted. So it would be a bit strange for an access list to permit everything at the bottom. So we've got incoming traffic 172.20.1.1. So you go through this access list. It doesn't match any of the rules on the access list. Now, as a safety precaution, this implicit denial says, well, you haven't told me to permit this traffic, so I'm going to deny it. The other thing is, which people get stuck on, is the router can't filter traffic that is generated from itself. So an example, we've got an access list on the router, deny traffic to 172.16.1.1. The PC on the inside of the network is pinging a PC on the outside, and it says ping 172.16.1.1. The traffic hits the router, looks it up and says, no, I'm actually blocking that traffic. Now, if via the router you ping the host 172.16.1.1, the router shouldn't inspect its own self-generated traffic. Now, you may find that it doesn't behave in the way I've just said, but this is the general rule on routers. Technology changes, iOS changes, and the router models change. But the general rule is, if you send a ping out self-generated from the router, then the router won't inspect it itself. Now, you can't edit a live access list. So if you've got one configured on your router and it's doing its job on the interface, you can't go in and edit it while it's working. Now, this rule applies for standard or extended access lists. It doesn't apply to named access lists, which you can edit. So the way to do it, try this when you're doing a lab, but you need to basically remove the access list from the interface. A lot of people make a mistake and they delete the entire access list of, say, 20 lines, which doesn't make sense. All you need to do is deactivate it from the interface that the access list is applied, and then what you can do is go into your running config. You could do show run, for example. You copy that access list into Notepad, edit it in Notepad, and then you go back into the router and you reapply the access list and then do a show run. Rule number 6. You can disable the access list on the interface, which is what I mentioned before. So to apply it, if it's access list 101, you type IP access -group 101 in. Why you call it a group and not a list, I don't know. It's just the way the programmers have got this all set up. So in order to disable it, all you do is type that command out with a no in front, and that will stop the access list being processed on the router, but the actual access list will still be held in the router's config. You can use an access list more than once. Some people don't seem to realise this either. If you've got multiple interfaces, you're allowed to use the same access list. You could even use it for your NAT if it fitted in, and to do any debugging. So I've got an example here, 2 different serial interfaces on the same router, and the access list is used at the same time. And keep them short. This actually looks like 2 rules to me. Keep your access list as short and neat as possible, and the most specific rules at the top. So if you've got a particular host that needs to be denied, it goes nearer the top, and then networks further down. So you can see I'm denying a network here, permitting a network at the top, permitting a specific host next down, permitting a network, and denying a host at the bottom. So if you've got a particular host address, you put it closer to the top. So there we go. The reason why we do this is your router access list takes up CPU cycles. So every time it looks at the line, it processes CPU cycles. So if you've got a specific entry, it goes further up the top, and basically your router will consume less CPU cycles, deal with the access list, and then be able to dedicate resources to doing other things. If this access list is referenced regularly, say every second or every few seconds, the router all the time is going to be doing a process from all the way from the top down to the bottom, and then taking an action when it gets to the bottom. Alright, so you're going to hear different things about this. Cisco say to put an extended access list in a different place to a standard access list. That doesn't really stack up, to be honest, because if you put, say, a standard access list close to your LAN side, but the traffic's coming from your wide area network, the router has to bring the packet in, it has to do a routing entry, decide which interface to send it out, then when it gets to the interface, the access list is inspected and the traffic is dropped. So I always say place the access list as close to the traffic source as possible. Okay, so they're the main rules. Please get these into your head, learn them, do some labs, and then come back and then check the rules again just to confirm that you understand how they all work.